You have a model, and you have a texture that you want to apply to it. The question is, how do you apply it to the image onto a 3D object? The answer is UV mapping. It allows you to represent 3D model in 2D space. This is done by creating seams on the model's edges and then unwrapping it. This results in two-dimensional representation of model, also known as UV map. Thanks to this, you can apply any texture to a model. And this works for all models with proper topology. And the whole process is like origami. Typically, working with UV happens in two windows. One with a 3D view of a model, and another with UV editor. You create seams on 3D model, unwrap it in the editor, and adjust the UV map as necessary. During this process, a checkerboard texture is often used, to see how a texture will look on the model. When you're satisfied with the result, you can simply save or export the model wherever you need. UV information is stored together with the model, so there's no need to save it separately. But when exporting, check if it will not be deleted. Let's talk a bit about the UV editor. Here you will see UV map and perform all actions with it. The square area in the center represents the UV coordinates, with values ranging from 0 to 1 in the U and V directions. Your texture will be applied on the square later on, and the parts that overlap a UV map will be displayed on the model. In the editor you can move UV vertices, edges and polygons just like in 3D, but this only affects how the texture is applied. Various tools are also available for working with the map, but we cover them later. There are no technical limitations to creating a UV map. You can cut a model in any number of pieces and place seams wherever you like. However, there are certain rules for doing this better. Watch out for distortions. In a complex geometry with improperly placed seams, a texture you apply may end up looking either stretched or squeezed. The program you're using should have a way of showing how much UV map is distorted. Seeing this, you can either remove seams, or manually edit the necessary part of a map. Don't create unnecessary seams. Each separate part of a map is called an UV island. Try not to create unnecessary ones or place seams everywhere. The easier UV map is to understand, the better. If you can understand what the model is and where each part of it is just by looking at the UV map, then that's a good UV map. It's better to place seams in inconspicuous parts of a model. For example, for a human, this will be parts covered by hair, underarms, feet, and etc. Pay attention to UV island sizes. The size of each island must match the size of a model part. For example, the torso of a human will take up a larger portion of the UV square, while a head or hands will take up a smaller portion. This is to ensure that the texture you apply has the same resolution across the whole model. The larger the island, the higher the resolution texture you can fit in it, resulting in a better quality. However, sometimes this rule can be broken, and more important islands can be made larger, while less important ones are made smaller. For example, the character's face may take up more space, while the feet may take up less. Islands should be placed as close to each other as possible. This is to maximize the use of the texture you will be applying. If a model has an untellable texture, a map should be within the UV square. If you cross its boundaries, various issues may arise while creating and applying a texture to a 3D model. However, if you have a very large and complex model, you can use multiple UV squares. The UDIM workflow is used for this. However, it's a bit more complicated to work with. Now let's talk about the main tools used when working with UVs. First, projection. Initially, the model may not have UV map at all. However, it's necessary to create one, so that you can mark seams and edit it later on. Projections are used to create this initial map. It's like taking a screenshot of your 3D model, allowing you to display it in 2D. There are different types of projections that determine how the software will take the screenshot of 3D model and where it initially placed the seams. Some of the most common UV projections include camera projection. Use this projection if you want to do all seams by yourself. Planar projection, used for the flat surfaces such as walls, floors, and ceilings. Cylindrical projection, used for the cylindrical objects such as columns, barrels, and pipes. Spherical projection, used for the spherical objects such as balls, globes, and spheres. Cube projection, used for the objects with complex shapes such as cars, buildings, and furniture. And automatic projection, attempts to find the best projection for your model. Second tool is unwrap. After marking seams, you need to apply the unwrap command that will, unwrap your model. Depending on the software, the command may differ, resulting in different outcomes, and there are also several settings you can adjust to get the best results. So, you can sew each created seam either on the model itself or in the UV editor. Layout. This command automatically arranges UV islands within the UV square. It also has several settings that can be useful for you, so check them out. Straighten. As you can guess, it straightens your UVs. Grab. Allows you to grab and pull UVs. Relax allows you to smooth out your UV layout. Pinch guides UV vertices toward the point you choose. Pins allows you to pin parts of your UV layout from editing. And the final one, stacking. If you have repeating elements in your model, you can stack them on top of each other in a UV map. They will all have identical texture, but you can use more texture space for other parts of a UV map. Now I would like to tell you about a few techniques and problems that you may encounter when working with UVs. Pixel bleeding. It's an artifact that occurs when applying a texture to a 3D model surface. It happens when texture pixels bleed into neighboring pixels or UV islands due to the sampling inaccuracies, interpolation, or anti-aliasing. As a result, the texture appears to be bleeding outside its intended boundaries, causing visible seams, artifacts, or blurring. To prevent pixel bleeding, several techniques can be used, such as increasing the resolution of the texture, adding padding between adjacent texture areas, adjusting texture filtering and sampling parameters, or using texture compression algorithms to minimize compression artifacts. Textile density. Texture density is a measurement unit used to make models' texture cohesive compared to each other through your entire world. But I won't go into details, as this is a fairly complex topic for which I may make a separate video. If you see problems in your project similar to those on screen, know that's a problem with the textile density. Checkers. Don't use just a black and white checker. A checker should consist of several colors and have a name in each square. This will allow you to better understand how the texture is applied. You can download checkers on the internet or make your own, for example on UV Checker Mapmaker site. Triplanar projection. In some cases you can use a triplanar projection. This is a special type of projection that projects a texture from each side and blends it at the boundaries. This method is suitable for tileable uniform textures and allows you to avoid making a high-quality UV layout. Auto-unwrapping. Some programs have a feature that automatically unwraps a model. However, in most cases it needs to be corrected, but it can serve as a starting point for work. There's also semi-automatic unwrapping. In this method, you draw on a model with a brush where you want to see seams and where you don't, after which your program creates them. Software. Almost any program with modeling tools has UV tools, even Unreal Engine. They may differ in the ease of use and speed of work, but it's subjective and depends on your goals and approach to work. Usually the optimal solution to use UV editor in a program you're working in, if you don't have a very complex model or don't need to unwrap a large number of models. In other cases, you can use more specialized software depending on your requirements for it. Let's summarize. Think about how high quality UV map should be. Can you use automatic unwrapping, apply triplanar projection, or maybe a model will have no textures but only material. If high quality UV map is needed, create a projection, mark seams in inconspicuous places, and unwrap the model. Refine the map with various tools, remembering to pay attention to distortion, island sizes, pixel bleeding and stacking. Use the right checker during the process and if necessary adjust the textile density. After all that, you'll have an excellent UVs. That's it. I wish you a quick unwrap and thank you for watching.